Our next technical paper presentation is Transformer LT Cable Box Health Monitoring System, Tata Power Company, Carnac Receiving Station. Yeah, who will be presenting? You will be presenting.
Good afternoon. Myself Nandakumar from Tata Power Transmission Division, Carnac Receiving Station. I am here to present about a project which is Transformer Cable Box Health Monitoring System. In transmission, a major equipment is a transformer. So any forced outage or any plant outage on transformer is going to directly hit our grid availability. Out of that, cable box outages is one of the major contributors for transformer outages. About 20% of forced outages which we recorded last 5 years are of transformer cable box only. So to address this issue, we want to devise a mechanism for monitoring the transformer cable box system in order to avoid this forced outages and also planned outages. These are some major causes of breakdown due to transformer LT cable box. To understand about LT cable box, this picture just represents the LT cable box of a transformer. It's just like a cuboid where the transformer LT bushings comes out and this cables goes and connected there. Major causes of transformer LT cable box breakdowns are dust, moisture ingress, condensation, surface tracking inside the LT cable box, mechanical load on cable terminations, partial discharges inside the cable box, aging of gaskets, hotspot at busbar holes and cable terminations, oil leakages, heater cable in arcing zone inside the cable box, and aging of PILC cables. These are some major contributors for shutdowns in the transformer cable box. The idea for development, we just want to devise a mechanism to monitor this transformer cable box health. So there was a brainstorming session which was conducted to devise a mechanism. The mechanism should also address all the major causes involved in the transformer LT cable box. The monitoring device should be compact enough to fit inside the transformer cable box and should have sufficient clearance from the live parts inside the cable box. And the data should be available in remote end for the user to monitor and take actions. The components which we used inside the transformer cable box for the monitoring system, we use thermal imaging sensors to monitor the hotspots inside the transformer cable box. Temperature and humidity sensors to monitor the temperature and humidity inside the transformer cable box and activate dehumidifiers. We also had a compact dehumidifiers inside the cable box which will activate once the humidity rises. There are wide angle cameras with flash inside the cable box by which we can monitor the real time monitoring of the cable box, any condensation or any moisture, those things. And use a communication switch and also a monitoring PC to monitor the transformer cable box health from the remote end. This is just a picture of a cable box, how it looks like. This is a cable box. This is the inside picture how it looks like. There are bus bars, insulators, cable terminations. This is one system which we installed as a pilot project inside the cable box. This small box includes thermal sensor, a wide angle camera, and humidity and temperature sensor. And this one small one here is a dehumidifier. The thermal sensors, after we installed, we just simulated them to check how it works. So these are some hotspots which we created manually inside the cable box to check. This was a cable health monitoring system, how it looks like. It gives a view of the entire cable box. A person can view this whenever he requires. There is a flashlight also. Now, normally the cable box is a closed chamber, it is dark, so flashlight is installed in it. And this is the thermal images it gives. These are arrays, and while we installed only, we simulated them and checked based on the cable terminations and all. The communication part of it, the transformer, cable box, all the sensors and cables we are covering, brought it to a small processor, and from processor we laid a Cat5, Cat6 cable, and it comes to a communication switch, and from the communication switch it goes to the control room for the user to monitor. This is how the monitoring system looks like at the control room. The user can directly see the cable box, view of the cable box, and he can also monitor the thermal images from there. The benefits of this cable monitoring system are real-time thermal scanning of transformer LT cable terminations is available. Live feed of the cable box view is available, by which abnormality like moisture ingress condensation can be detected. And 24/7 live data is available in control room for user to monitor it. Data of thermal humidity and temperature are captured, which can be used to provide notification alert to users in case of deviations. Whatever the thermal data we capture, we are storing it in the background, and if any changes in the temperature, it directly pops up a notification for the user that there is some abnormal in the system. So the user can take actions based on that. And customization of device based on user requirement. Alert notification to user. Alert notification to user is available if thermal temperature and humidity data exceeds predefined value. And way ahead of what we have planned, real-time data will be made available in mobile app also for the users to monitor from anywhere. Maybe because the engineers are always on the rounds, and he cannot view the data in the control room. So it will be available in the mobile app also. Notification alerts will be given in mobile. Camera with digital zoom facility will be made available. And we are also exploring the possibility of putting a partial discharge system to capture the PDs inside the transformer cable box. The impacts it has created on our key performance indicators. Forced outages pertaining to transformer cable box can be avoided, because we don't have to take outages, planned outages, and also forced outages can be avoided. Measurable reduction in forced outages and improved transformer availability. So if you can avoid outages, obviously the transformer availability is going to improve. Achievable. Outage for cable box inspection may be deferred with online monitoring. Purposely for this cable box inspection, we don't have to take outages. 24/7 live data is available in user control room, and grid availability will be improved because of this. Thank you.
That's the need for thanks.
I have one question. You have not attempted to solve the root cause for each of these problems. As a matter of fact, there should have been generally it is understood that the cable box should be hermetically sealed.
Yes.
But why it could not be achieved hermetically sealed? That means there will be no ingress of moisture, no ingress of dust. Why that cannot be achieved, and you are circumventing by other methods and putting new instrumentation? I am not saying it is not wrong, but why I am trying to say why those root causes cannot be sorted out in a manner instead of getting into a new problems.
Hermetically sealed, we faced issues of condensation inside the transformer cable box, and there was a solution later on to provide lowers for the, because to equalize the temperature outside and inside temperature, so that there is no condensation formation there. But after this, also we face some issues with moisture ingress there. And which,
Sir, I will just support his question, what he said,
Yeah.
Yes, sir said, that in a marshalling box, in a transformer cable terminal box, why don't you put silica gel, simple solution?
transformers comes with the silica gel.
And then, what is the issue? Then why you are still getting moisture?
But still, due to these things we face during monsoon seasons actually, when there is a sudden temperature difference is there.
But when there is no moisture, condensation will not come. If it is totally moisture free,
Yeah.
because of putting silica gel, then it will condensation will not come. Very simple solution.
No,
And in
this
spite
way-
of that, you have gone for hi-fi. Definitely, you have done something great.
With silica
But
gel,
why
we
this
face
hi-fi
the issues.
instrumentation system was required? That is my question, and I think he is also trying to answer this, asking you the same question. This is my query.
In experience, we have faced that with silica gel also there was condensation in the system. And then there was a overall brainstorming and they came up with lowers as a solution for that. And with lowers also we face this moisture ingress.
And the dust will also go inside.
Yes. There will be filters like
Yes, it-
in the lowers.
Most of the problems are erection problems, like heater cable coming in arcing distance.
Yes.
Yeah, this is absolute ridiculous. Should not happen.
That there was an issue of tripping because of that.
Ah,
So
but when you present, you should avoid such
okay, those
such things which are installation problems.
Any other question, please? Because I am not very much convinced the way you have presented, though I have my entire life I spent
Now,
in.
have you been able to put it up for prudence check with the regulators?
no, not yet, sir.
Which might have come in way now.
It is
OPEX. OPEX item.
It's OPEX,
Yes.
not CAPEX.
Right.
This was a pilot project actually. We just installed 2 months before.
Sai, sometimes we want to become hi-fi, and we normally forget the very simple
See,
solution.
every time hi-fi creates more problems rather than.
Hi-fi creates high problem.
I am not belittling your efforts because you have gone through innovation, you have gone through new thoughts, we have put so many things into that. But adding more instrumentation is always something which is not called for.
Right. Any other question, please? Anybody?
Any rainwater entry into the system, that is why it is.
Not rainwater entry, because of rains what happens, your cable box will be normally hot. And during monsoon the outer temperature is low. So there is a formation of condensation inside.
Inside condensation.
See, this is you say it's a pilot project.
Yes.
Now, this is looks like a 60 MVA transformer.
One is a 90 MVA transformer.
Oh. So, there must be some, how many number of transformers or what is the rating that you would like to introduce this? That is one question.
Okay.
Then yours is a small utility as compared to the entire Maharashtra, entire India. So this is, if this is to be replicated as a standard solution, would it be possible cost wise?
No, because these thermal
And
sensors-
is there any other alternative to this which is not so costly?
No, whatever sensors we have taken are of low cost only, because they are like a flare sensor. If you use it, it is going to be very costly. In my case, I used a very low cost thermal sensors and temperature and humidity sensors and a simple camera. The major cost will be less than 50,000.
I see.
Sir, in addition to my colleague's presentation, last year we have done a paper presentation of dehumidifiers that was inbuilt in Tata Power that we have installed in all transformer cable boxes. So that was a 2 Peltier mounted cable boxes. And there is a 1 Peltier. Outer temperature is very high, and there is a small box below that Peltier. So it will collect the moisture from the inside the cable box of transformer. It will cool it down, and when water droplets are made, it will through a pipe it will
Okay.
remove the moisture. So along with this project, we have installed dehumidifier also. So this is for condition monitoring of LT cable box as well as whether any water droplets are made inside the cable box.
See,
So,
anything you make should be scalable.
yeah.
That is not just a pilot project, but
Yeah.
applicable to
So
many
along with this dehumidifiers, we have installed this camera mounted and this hot temperature also. And we are planning for horizontal deployment across the transport.
Last question, huh?
Hi. Actually, it is a fix and forget, or we need to do any maintenance for the thermal sensor, or any calibration required in a periodic time. How to do it?
Like calibration as such is not required, only we simulate it when we fix it. Yes. We create a hotspot and we check it when we install it, and that's the first time, one-time installation that.
Thank you very much. Thank you very much. First of all, you have completed much before time. We gave you 30 minutes. We could finish within 10 to 15 minutes. That was a blessing for us.